educated, but I'm so frustrated. Hello to my loneliness. I guess that ignorance is bliss. Take me back to before the new. Rewind, take it out of cue. Innocence can be a young man's game. Signed up for the hall of shame. I wish I knew how much I miss not knowing that we're all screwed. When we play our roles and ignore the problems. I like to be away in my patience. Stay up, I feel so outdated. How can we look the other way? Sun is out, but the sky is gray. What would happen if I took a chance? It's always hard at first glance. I don't wanna, but I know I gotta do it. The truth is hard to swallow. I think I'll chew it.
Buongiorno a tutti e benvenuti a questa quarta edizione del Think Tank.
Welcome and thank you and welcome to the fourth edition of IVS Valve Campus Think Tank. This year there's a novelty because the think tank has officially become part of the program of the IVS exhibition in Bergamo. This is an important event because it's a signal that this is an interesting and attractive product. And above all, let us not forget that it concerns our supply chain and it wishes to be an introduction to our showcase on the world. That is the exhibition which is held every 2 years in Bergamo, specifically for the oil and gas industry. We've prepared a program for today's event. We hope you'll find it interesting. It's very tightly packed, and so I'd like to give the floor, without further ado, to Luca for his short presentation as the project manager of IVS, our hosts today.
Grazie Francesco.
Thank you very much, Francesco. Let me also thank Virginia Grazzi, Francesco Apuzzo, and the campus for organizing today's meeting. You know that we have been hosting the Think Tank event for the last 4 years. Used to be a marginal event to the IVS exhibition. Now it's part and parcel with the IVS exhibition, which takes place every other year, and which is a reference exhibition in the industry.
La Fiera IVS, come sapete, è una fiera che c'è stata quest'anno nel 2000.
The IVS exhibition took place in May 22. The next edition will be in 2024. The first event towards the IVS 2024 is today's conference. With my presentation, I will introduce what's happening. I will be talking about the latest developments in the industry. We'll have eminent guests who will be telling us about the future of this industry. Our task is also to explain and see how we should adapt ourselves, and we should adapt what we do according to the latest development. We now have the Bergamo Chamber of Commerce data proving that industrial production is growing. Not with the pace we were expecting, but still it is growing, as well as exports. We have full employment rates, which is indeed a very good piece of news on the one hand, but it means that it's not easy to find talents. However, there is a certain degree of uncertainty concerning new orders. What about the global framework? There are criticalities in terms of raw materials, price, availability, deliveries, the energy prices going up, the emergency due to the Russian and Ukrainian war, the variability of the international geopolitical background, not just Russia and Ukraine, but think about the situation in China. This is an area we should keep a sharp eye on, risks of closures and so on and so forth. And then Iran, the Italian manufacturing industry will be faced with sanctions against Iran, so we won't be able to sell to many Iranian players. Unfortunately, the situation is not really improving. Another issue is the oil and gas supply chain. I'm not an expert in the field, but our producers and our members tell us about the uncertainties concerning the oil and gas end users' investments. What about the new markets? We have seen a geographical shift in terms of our exports. The Russian market is closed down. We had to look for alternative markets, and which meant that we also had to look for different supply chains. What about the energy scenario? First of all, we had the pandemic, and then the Russia and Ukrainian war created a shock on the market. We had to look for alternative supply channels. New infrastructure is needed. Think about the Italian regasifiers. There is a lot of uncertainty concerning oil and gas prices. New investments in oil and gas mining and refining. We now need to find fossil fuels because of the situation in Russia right now. And then investments in renewable energies. Today we will be talking about hydrogen, and we know very well that the use of hydrogen is strictly intertwined with the production of alternative energy. And then investments in carbon-free energy sources and investments for the production of low-carbon energies. This is another huge topic, very important for end users and suppliers alike. So these on the slides are just some examples of the current situation. Today we're going to talk about the energy transition, which means we will be talking a lot about hydrogen. This energy transition will be driven by hydrogen production. The production of green hydrogen accounts for less than 1% of the total production, which means that we will have to work hard on alternative and renewable energies, solar, wind. Europe is investing massively. I know that many of you are investing on panels in order to reduce the cost of energy. Biomasses, and I did not include nuclear because there is still a lot to do in the nuclear field, but we know that nuclear will be one of the main players of the energy transition. Methane, we're all talking about CO2 reduction, the need to reduce CO2 emissions, but we know that a heating effect of methane is even stronger than CO2, and we know that methane stays in the atmosphere for shorter period of time than CO2. which means that if we want to hit the 2050 targets, we have to reduce the emission of methane, which, and this not just in terms of energy production, but we also have to reduce emissions. And this, of course, has a lot to do with valves. We'll have to manufacture plant valves which allow us to reduce the emissions of methane much more than we are currently doing. But this also means that we have to work with farmers and animal breeding farmers, which of course account for most of the emissions. New industrial equipment. We talked about the hard-to-abate plants where there are areas where carbon neutrality is quite difficult. However, some help is coming from technologies. Technology is going to help us to reduce emissions from industrial manufacturing, industrial activities. New investments will be needed in infrastructure, and this again an opportunity coming from the energy transition. Think about the distribution, the electrification, think about taking energy to small villages across the globe, maybe by making use of hydrogen. And there are so many places in the world which have no access to energy right now, to power right now. If you look at hydrocarbon producers, and if we look at their targets, 2050 targets, well, everyone is talking about decarbonizing transports. They all talk about producing new fuels, so transport will play a crucial role in the future. I don't know whether you can... I think there is a problem with the slides. Apparently, there is one slide on one part of the room and another one on the other side of the room. Okay, never mind. I hope the technicians will help me. Anyway, so we were talking about energy transition and about energy scenarios, and I think I have outlined some of the main scenarios. There is a huge gap between what we're doing based on the expectations and based on the government's announced pledges and what we should be really doing in order to achieve a full decarbonization. What you have here on the slide is again the energy world. These are the targets set by the Oil and Gas Climate Initiatives. This is an organization putting together or joining together hydrocarbon producers. There are three main targets. First of all, reducing methane emissions, the reduction of CO2 emissions, and the final target is the use, the so-called carbon capture and storage of carbon, CCUS. So let me thank Val Campus and all the entrepreneurs that have been with us over the years. As you can see, we started back in 2015 with 150 exhibitors with 6,000 visitors. And this year, we have 12,000 visitors and 300 exhibitors. And this despite all that has happened in the world. What can we do? Well, the first thing we can do is organizing occasions to meet up and to do joint research works. With Promethea, we have launched a survey and a research program to get a full picture of the market. But we've also started an internationalization process. We have many international cooperation. We now have a delegation from Iraq. There are also European, Spanish, and UK valve producers, organizations we are partnering with. We also have partnerships with industry associations, Valve Association, Corrosion Association, and so on and so forth. We have a full coverage of all the different industries. We also take part in industry exhibitions, including Valve World, which will take place next week. We also have partnership with industry exhibitions, including Speakonx. I apologize for the interruption. So I was talking about the partnership programs and the events we are attending. I wish you a very fruitful meeting, and I stop here.
Here I am. So I hope that everything goes well with Mr. Pandolfi. I'm sorry, we just was a little dizzy. I don't really like to speak from a stage. Can I sit or stand wherever I wish? Good morning. I'm Sisi Bellomo. Perhaps you'll remember me in previous editions of these update events. Perhaps you read my articles on Il Sole 24 Ore, where I write on and on about gas, oil, and energy. But in truth, I also deal with other raw materials and the metals you use in your industry, but increasingly less, as energy is now at the very center of the stage, and other raw materials too, like agricultural produce. So I'm here to take stock together with you, with my untidy and destructured habit, as journalists usually do. And I hope I will just speak of real things. Listening to what Mr. Apuzzo and Mr. Pandolfi have just said, I wanted to help you to focus better on this exceptional moment in time which we are witnessing as citizens, as countries, as geopolitical balances, and above all, in the field of energy. It is under the eyes of us all what is happening with the war in Ukraine, as you heard, which has indeed represented a split, breaker for energy security, raw materials, feedstocks, a complete change, which many of us agree in saying is truly irreversible. It is highly improbable that trade relations and business relations or supply mechanisms with Russia will ever go back totally to how they used to be in the past. But this is also one of those events which rebalances relations and which leads to cultural changes too. We've already witnessed one globally with the pandemic. And this is another of those events which have triggered off a change process, which probably will require much time before it develops completely. Raw material prices, energy prices were already rising before the invasion of Ukraine, before the war, and before sanctions imposed upon Russia. So there's not just this in the scenario, but there is a final reorientation, as we were saying, of the business areas, the suppliers, trade relations, for a field like that of valves and many others. Well, Russia is a closed market, completely off limits, but it's becoming increasingly off limits to be able to use them as suppliers of materials, for example. And this is not completely off limits yet because Europe and the United States and the rest of the world too turned to Russia for the supply of metals like aluminium, but also pig iron. And there are also self-sanctioning mechanisms underway and the withdrawal from consolidated relations. Nickel, for example, in the steel supply chain, and increase in prices until the finished product, and the incredible price volatility. Russia is a supplier, and we will have a lot of difficulty to do without them altogether. And in this situation, and here I refer to this cultural and epochal change, because for years we've been used to facing up to a challenge which per se was already very difficult. The challenge of net zero. This is a taxing effort, an expensive effort, which I believe is indicated as something easy. Italy, there's a lot of sun, a lot of wind, there are a lot of tides. It's just lobbies. It's not just lobbies. There are lobbies of all colors, of all approaches. It's a difficult task which requires investments and to do things differently. So when faced with this imperative of energy transition and decarbonization, another very important trend has emerged. It's not brand new, but it has emerged more strongly. That is indeed something else, energy transition, because thanks to our relationship with Russia, and we know that Russia is closer, more available, more economic. And so we have been lulled by the feeling that everything is okay this way. Now it's easy to say we shouldn't have trusted Russia that much. Well, we shouldn't rely on any supplier, and yet we're making the same mistake because if you get rid of Russia for gas supply, we're already dependent 40% from Algeria. And at the moment, we perhaps like Algeria more than Russia, but we'll have to see how Algeria behaves in the future. And so the need for energy security, which requires this to be processed together with decarbonization. This is one very difficult challenge, plus another very difficult challenge to fight against simultaneously all together. And we've also got to balance our books because we've always have to bear in mind cost, opportunity, feasibility, realistic transition costs. We need more realism at a political level too in the situation of dramatic energy crisis, a crisis of raw materials, inflation, and an increase in prices of any input of production. And this is indeed being passed downstream, and we see this in our utility bills. And so this is a more realistic approach we need to adopt, and we can't just be super optimistic, but at the same time it's true that it's from crisis that opportunities are born. So if we look in a more practical way at those areas which concern our audience, interest our audience more, there are some matters, some issues which open up again. Opportunities which were traditional and which could give us a breather. And one of the previous speakers mentioned the more gradual transition underway, which, without killing off the push towards decarbonization, because there's an acceleration of investments in renewables and also in the authorization processes, and let's hope that this happens increasingly. But some new opportunities are opening up, opportunities which we thought were dead. Up to last year, none of us would have bet on the launching of major gas pipelines. It was very difficult for this to happen. Up to a short while ago, people were discussing whether gas and nuclear energy could be included in the taxonomy of the European Union. Whatever has even just sniffed of fossil fuel appeared to be banned, not just for ideological reasons, but also for aspirations. However, some traditional opportunities are opening up. Gas pipelines, yes, we're back discussing this. Not just the enlargement of existing networks, the doubling of TAP. It's not just a question of adding compressor stations, after all, but there's a project like the ISMED gas pipeline, which is seen with great favor. I never really believed in this. It was a political project above all, but as it is a political project and it helps us to diversify our supplies, well, this could give us a final push, a great gas pipeline in our sea with an underwater compressor, business opportunities. I don't like to sound very cynical, but I think I'm speaking to an audience of entrepreneur, practical people. I'm not being cynical, but I just want to be practical. Regasifiers, these mythological regasifiers, which for decades, for years, Italy should have had. It would have been better to have them, but they were no longer being built. But now a couple of regasifiers are about to be built. They'll have to be connected to the grid. We're speaking also of land-based regasifiers in Italy too, as well as in the rest of Europe. The projects announced or even already built of new regasification plants can be seen. You can actually count them. Germany has just endowed itself with its first regasifier, and now it's coming from a ship. There's a regasifier in Holland, one of the main reasons for which the gas prices have dropped compared to the summer. If you wish, we can speak of this in greater detail later. But there are projects which are once again seen favorably, also in the field of storage. We have a representative of Snam. Snam has important gas deposits and intervenes on its efficiency and the pressure of these deposits and wishes to create new further ones. And this is something normal in the traditional field of oil and gas. And there's also recovery at a global level, resumption, shall we say, in exploration and production of the upstream part of oil and gas for a second consecutive year, 2022. But these investments are accelerating further. And analysts tell us that in 2022, there's a first resumption which is coordinated internationally. North America, the Middle East, areas which have never stopped investing in this field. But for the first time, it's coordinated at a world level. It means Europe, it means in my backyard, indeed in Italy, where perhaps there's not that much, but perhaps in 30 years' time, there'll be new concessions in the Adriatic, in the northern Adriatic Sea, which was believed to be off the map completely. And this creates a greater push forward compared to the past to complete the Adriatic line, internal gas pipelines. The market is integrating, it's strengthening, and there's a market push towards this in order to obtain more energy security, also in the conventional industries in oil and gas. And then something else which is really increasing is investments in renewables. In the grid, there's a lot of that. Many of the investments globally as the last study of the International Agency for Energy reminds us, often questioned, but in terms of data collection and everything we do at an OECD level, we see that the power industry is really acting as a thrusting force. This means storage, increasing the power of the grid. We close other windows because energy transition is slowing down. Let's hope it's not going to slow down too much, especially for coal plants. And these were being reconverted, and there was a lot of business around this closing down. And some have decided not to do anything. The Civitavecchia coal plant, which was meant to be turned into a gas plant, there's a rethinking of the coal plants, and this is creating problems also for companies working in the plant supply chain, plant construction supply chain. And then there are new opportunities, very interesting ones in the world of hydrogen. In the course of this afternoon, we will have a dedicated roundtable, a focus on hydrogen opportunities, because hydrogen is privileged in the decarbonization policies. Excuse me. I'm not feeling ill, but I have a hoarse voice. Hydrogen has been seen as one of the thrusting forces of this energy transition. It receives a lot of investment funds, incentives of different kinds, and hydrogen represents, as we heard previously with some journalists who came to the press conference for the presentation of this event, hydrogen is truly the field where we can more easily find synergies with the traditional valve industry, and where we can evolve with greater facility and ease. And as we will see in our roundtables, this implies a need for new research, materials, projects. We have to be very aggressive. And in a stage like this one, where the panorama is very uncertain and where we no longer know exactly how to move from various viewpoints and even make forecasts on energy costs and to face up to this price volatility, these important question marks on what will happen, even in a time span which is rather limited. And this complicates our way of relating with customers and our way of planning change, necessary change, or induced change in order to prevent a series of risks which have increased enormously. There's an enormous amount of risk, and it's actually more difficult to defend ourselves from these risks if we don't have a projection which is at least relatively reliable as to what will happen in the future. We look at markets, and we journalists, for simplification sense, they say that gas will cost more than 100 euros per megawatt hour, but exchange rates change every day. You can't say that the projections of future or forward contracts will absolutely be true. Perhaps instead the prices will be very low, because after 2026 there'll be a lot of energy in circulation, or we'll be so clever that we won't need that much energy any longer. And to plan our investments and our business strategies, it is to be hoped for that there is more clarity. Plus the trade wars. China, an enemy or a friend? Must we boycott China like Biden says, or should we start negotiating again like the Germans say? And amongst us Europeans, we see that there is some lagging behind in terms of solidarity. We in Italy should act at a European level for gas and for the supply of other critical materials and raw materials. But in difficult moments, we see that solidarity is indeed lacking. No one has a crystal ball, but I think that in this stage, even the most careful analysts and experts in economics or just simply the markets of raw materials truly have difficulty in reading the picture and understanding what is happening in 5 years' time. That is net zero. So today we will try to just try to get around this labyrinth and try to shed light on real practical opportunities, the newly born ones. For the moment, I'll stop here and I give the floor to the other presentations. I wish to invite Paolo Carrera, who's the business executive of H2 Energy. As energy will be H2. It's a lovely title. And he'll tell us about hydrogen. And as we said, this will play a central role in our future strategies. Thank you.
Good morning. Well, I will start with a presentation to introduce the upcoming roundtable. I know that we think that hydrogen will be at the very center of the new energy role. I will show you the slides, some slides showing what another Italian company is doing in the current context. Can anyone help me with the slides?
Ci dovremmo essere. Diciamo che dunque non si può parlare di idrogeno senza parlare di transizione energetica.
We cannot talk about hydrogen unless we talk about energy transition, and there will be no energy transition without hydrogen. Here you have 10 facts from the IEA, which are useful to start talking about hydrogen. As somebody said before, reaching economic growth without increasing the greenhouse gases emissions will be almost impossible. We are talking about less than 1% every year. So if we want to achieve economic growth and energy efficiency, we have to do something more. Probably we have to develop more innovative approaches. Energy has a very strong impact on our climate. It accounts for 2/3 of all greenhouse gases. Therefore, we need to develop applications which use less energy, are less expensive, and also will enable users to have access to the energy transition. And this is absolutely crucial. We're all talking about natural gas, but moving from carbon to natural gas will have a strong beneficial effect on the reduction of CO2 emissions. We shouldn't forget that world gas reserves are abundant and available. Capture and CO2 capture and storage will be key in order to achieve our targets. Finally, electric vehicles will give a fantastic contribution. Wind and solar, onshore wind and solar, particularly in some geographies, are the cheapest power sources. Up to 20% of power is lost during transmission and distribution. Therefore, smart grid technologies will be crucial in order to reduce losses and to reduce CO2 emissions. Energy storage was already mentioned. It'll be key in this energy transition. We're still at the infancy of these technologies, but this is an area where a lot of investments and initiatives and innovations will be needed. The energy industry uses 15% of the world fresh water, available fresh water, and 2/3 of the world's population has no access to fresh water, or at least is faced with a freshwater shortage. If we decide to continue using fossil fuels exclusively, we won't be able to reach our 2050 targets. It is equally true that renewable resources alone will take us nowhere. Now, let's start talking about hydrogen and the net zero emission 2050 scenario. I'm showing you this slide. This is the contribution of the different sources to the net zero emission 2050 scenario. This is a scenario a number of European industrialized countries have committed to. The idea is to reach these levels in order to reaching the 1.5 degrees temperature increase rather than the 2 degrees, which will be really bad. Please pay attention to, and this again, the source of this slide is the IEA and the Rossetti House. Well, 13% of the contribution depend on our own behaviors. So no technology, no innovation will be needed. Behavioral change will account for 13%. So yes, the energy transition entails a lot of technological development, but also a lot has to do with our own behaviors. Let's have a look at the role of hydrogen. We know that there is a lot of availability. Hydrogen is highly available in the world. It is described as the star fuel. So we know a lot about hydrogen. This slide refers to green and blue hydrogen, meaning hydrogen produced by renewable resources, or hydrogen which is associated to CO2 reduction. It's a highly versatile, clean and safe energy source. It is incredibly volatile. It can be used either as fuel or as feedstock by the industry. It can be produced either by renewable energies or by the carbon-abated fossil fuels, methane, which is associated to CO2 abatement. It does not produce emissions at the point of use. It can be stored, it can be transported. It's highly efficient, both in gas and in liquid form. Finally, it can be combusted or used in fuel cells to generate heat and electricity, which means hydrogen is highly versatile. Now, let's take a step back and let's go back about the net zero scenario. Right now, we are producing 94 million tons of hydrogen, and less than 1% is low emission H2. We want to double production, reaching 180 million tons, but the big challenge will be making sure that 50% of this production is a low emission H2 production. This slide shows some of the challenges we have on the market, on the hydrogen market. So 180 million tons will be produced. I mean, 2/3 of it will be produced by electrolysis, and 1/3 of it will be produced differently. The electrolysis will lead to 700 gigawatt of installations. Right now, less than 200 megawatts have been installed across the world. On the last line shows the 2050 targets, which means 7, 8, 9 times the current hydrogen production, and by 2050, all hydrogen should be green hydrogen. Very ambitious targets indeed, but we must also boost demand. Decarbonization will be incentivized by increasing the production of hydrogen. Hydrogen access should also be boosted by creating the right infrastructure. End users will have to be enticed to make use of hydrogen. And of course, costs will have to be reduced. We need economies of scale to make sure that this new form of energy is compatible with current methane costs. What can the government do, and what's the role of the private sector? Well, first of all, governments need to boost this energy transition by enforcing different types of mechanisms. For example, financing plants, or reducing taxation or increasing taxations on CO2, reducing taxation of hydrogen. Right now, the only incentives that we have in Italy is about transport. Right now, it's the price is set 19 cents per cubic meter. So in Italy, we do have some incentives for hydrogen used for transport. What's the role of the private sector? Well, the private players must believe, bet, and invest in this field in order to develop innovations. Now, I'd like to briefly talk about this company, which is based here in Bergamo, headquarters in Brescia, and laboratories and other departments in Cremona. We produce electrolyzers, meaning we manufacture machineries that take water to produce hydrogen and oxygen. And indeed, I forgot to tell you that one of the side product of the electrolysis is oxygen. And oxygen is another gas that we can extract value from. Well, I'd like to tell you that we are investing a lot in research and development. We have a highly advanced hydrogen laboratory, probably the most advanced that we have in Italy. We aim at innovation. We do catalyzers, membrane, we study materials. One thing will be blending with methane, but another thing will be producing materials that are compatible with hydrogen. We were among the very first one to take an electrolyzer, a PEM-based electrolyzer, to the Hanover Mess, which is the reference exhibition in the industry. This slide, well, I am not going into too many technical details, but we know that the most consolidated technology is the alkaline technology. But then you also have the PEM technology. We are investing in halfway technology, taking the best of both worlds. Well, in this slide, you can appreciate how complex a PEM piece of equipment is. A normal, traditional plant can fit a 40-foot container. You can see that you have any type of valve, actually, big quantities. This refers to 1 megawatt, 1 PEM megawatt. You see everything, thermocouple, chillers, deoxo, heat exchangers. So you see how complex it is. And you will also appreciate the fact that we're talking about noble materials. We know very well that hydrogen-based plants can be quite aggressive. I don't think there is any need for me to dwell too long on this slide, but this again proves that we are now moving towards this AEM technology, which the alkaline exchange membrane, which tries and use some of the benefits of alkaline-based systems, which is the value for money aspect. We are now developing a new AEM 200 and 500 megawatts. We are also working on cells in order to improve their design and also to contain the BOP costs. So the take-home message is that innovation will be crucial in this sector, and it will be really the main driver. I'd like to conclude mentioning this quote by Mr. Professor Benson, who's a teacher at the Stanford University. Basically, he's saying we cannot sit back and wait because it will take a long time. We should not be afraid by these long term targets. It's not a race. This is actually a marathon that many countries have already embarked on. Thank you very much.
Thank you very much. Your presentation is useful also as an introduction to what will start in a few seconds, because I'll give the floor to Omar Bedani from Wood for a focus on hydrogen and on the path towards the sustainability of the supply chain supported by Wood, with the support of other companies working with Wood. And the objective is that of bearing witness of how such complex challenges, difficult and long ones in such a marathon, allows us to work better by cooperating with other companies in the supply chain, because this can give better results. And so I give the floor to Omar Bedani, who will present his ideas, his projects. Thank you. Thank you very much. Thank you. I think that I'm actually a little too loud. Thank you and welcome. It's truly a pleasure to be here for the second year in a row after last year's intervention, organized always with Valve Campus. This year, the organizer, whom I thank very much indeed for having given us the possibility of using this workshop. Thank you to Valve Campus, IVS, and Virginia, Francesco Puzzo, Mr. Pandolfi. It's a real pleasure to be here with you all, with this audience, and to give you an opportunity to see what we're doing. Not so much to show off our technology, but to show you, as Sisi Bellomo said, how some challenges, which we sometimes have to tackle alone, when you work in partnership with someone else, end up being more easy to tackle. And so I'm going to ask the colleagues who will support me, or at least I will support the colleagues in this trip, to come and sit on the podium with me. I will introduce you to each colleague as soon as they take the floor. I think that's the best solution, so that you can memorize the name and the topic they're going to touch upon, and so we don't lose sight of what we're doing. A brief introduction, the workshop. Simone, go ahead. Sorry, I lost sight because you moved, you changed chairs. So, a short introduction on the workshop. We decided to call the workshop Together for Sustainable Energy. The key word is together. We're working together to give the market, the energy market, something sustainable. Why is wood here for this workshop, apart from the fact that we were invited, of course? Because perhaps you know us as Foster Wheeler. We have a long-standing tradition, especially as licensees of hydrogen production on steam forming technology, as the colleague said before. So we've always been exposed to the hydrogen market, and we were amongst the first to have to stand up to the challenge of producing blue hydrogen, that is, hydrogen with a low environmental impact. No, it doesn't work. No. Can we speak without a mic? No, the interpreters will not be able to translate, I'm afraid. Okay, that was just an attempt. So we were amongst the first to face up to the challenge. So this is jewelry work, fixing the mic on my ear. So the challenge of producing hydrogen with a low environmental impact or with low CO2 emission. And so that's why we're here to present to this workshop. I don't want to take up too much time with my introductory remarks. There will be two main streams. The first is devoted to hydrogen. And as I said, this is the prince, the undisputed prime mover. A prince, but not a king yet, because hydrogen must still ascend to the throne. And then we'll speak of methane. As we said previously, methane has a fundamental importance. It might appear strange to say this nowadays, but methane, although it brings in its wake the famous CO2, the atom of carbon, is important to support transition and energy security. So without further ado, I'll give the floor to my colleague Valentina De Petri, who will present and guide within the hydrogen stream this discussion. Valentina is a colleague. She works in wood since 2016. It's 6 years now. And she is process engineer for hydrogen and methanation technology. She has a degree in chemical engineering at the Polytechnic of Milan. She's a very clever member of our technology team. And I give you the floor. Please guide us in the magic world of hydrogen. Let me move. Thank you very much for your kind words and introduction. Good afternoon, everyone. Great. I'm sorry, that's Mr. Pandolfi's presentation, not yours. Okay, here we are. So, as already said, the possibility of producing hydrogen in a competitive and sustainable way is one of the most important topics of international and national debates on energy transition, and the possibility of producing it in a sustainable and competitive way is the objective of this presentation. The possibility of using molecular hydrogen in sustainable processes does not have particular technological limits, as we will see in my presentation. So molecular hydrogen is mainly used in oil reforming processes and petrochemical processes. The product is large scale thanks to the reforming technology coming from fossil fuels. We at Wood are the licensee of a technology based on steam methane reformers, therefore a hydrocarbon system which can be fuels of different types with steam, producing therefore a a natural gas substitute. And this is where the chemical reaction takes place. The proprietary design of these furnaces is HC fuel, and it is specific because there are two terraces with inclined walls. This is the terrace wall steam reforming furnaces. This allows us to have a uniform thermal reaction where the catalytic reaction takes place and achieving the consumption of fossil fuel and the production of steam. To produce hydrogen in a sustainable way, however, it's not just important to optimize the consumption of load of feedstock fuel to reduce CO2 emissions, but it's also important to supply solutions which allow us to reduce the time and the cost for setting up these plants. And that is why a possible solution is this low-carbon hydrogen proposition which we propose. The range of feedstocks vary. This goes from natural gas to heavier loads, and also the capacity of these plants can go to 3,000 to 3,000 cubic meters per hour in a single train. To produce hydrogen in a sustainable way, we have developed within our group two different approaches of alternative technologies which allow us to respond to the needs of energy transition, that is blue hydrogen and biohydrogen. According to the raw material and to the supply of energy associated in the production of hydrogen, we have given hydrogen different colors. We range from green hydrogen, which is produced by the electrolysis of water through renewable sources for electricity, or we have blue hydrogen, which is produced by hydrocarbon feedstocks, which are typical of the grey plants, but they are integrated with a CO2 capture system, which allows us to reduce the CO2 emissions of these plants. To produce blue hydrogen, we have developed two different technologies, or shall we say, we've optimized our technology with two interpretations. It's important to remember that both of these technologies allow us to reach at least 95% of recovery of CO2 produced within the plants, and so consequently up to 95% of CO2 emissions reduction. Integrating within the steam reforming technology, system for the capture of CO2, which is called pre-capture, pre-combustion for the SNG produced within the plant. The second interpretation of the blue hydrogen technology is called Blue SMR Plus, and it foresees the integration within the steam reforming process of a new piece of equipment which we have conceived, planned and tested, and which allows us to reduce the residual emissions of CO2, reducing the carbon footprint of this technology. This is the so-called GHR reformer, gas-heated reformer. What is the gas-heated reformer? This is simply a vertical heat exchanger within which we have tubes of catalytic material, of catalyzers, in which the steam reforming reaction takes place. And the necessary heat for this reaction to take place is provided by the thermal exchange between the fresh feed, which enters the exchanger, and the aeration product, which happens in the furnace downstream in the GHR. It is possible to have other integrations and to use this equipment on a convection basis using hot, low-pressure currents with fumes. The advantages of this technology, SMR Plus, are an increase of process efficiency in terms of feed and fuel consumption, a reduction of the carbon footprint, and not just a reduction of the fuel, but also reduction of the steam produced within the process, improving thereby operational costs and investment costs too, and this above all with large capacities. The GHR has been tested in a pilot plant, which is in Jülich in Germany, through the positioning within a plant of this system, which foresees a solar integration. It is installed inside a test chamber in this tower, which is 33 meters from ground level, and which produces 127 nano cubic meters per hour of dry syngas. And this thanks to our partnership with Synhelion.
Unfortunately, the microphone is not working. Now it is. Quite loud, actually. Talking about Synhelion and the test on this GHR system, I'd like to introduce Gianluca Ambrosetti, who's the CEO and co-founder of Synhelio, which is a Switzerland-based, Ticinum-based company which has developed a technology for concentrating solar light that is then used to convert raw materials into liquid fuels. So this is something we know very well, but instead of coming from a hole drilled on the ground, coming from something much more climate friendly, which is the sun. Good morning. It's a great pleasure to be here with you, and most of all, it is great to be able to speak Italian. My company is based in Switzerland, in Zurich, so it's quite rare. It's a rare opportunity talking in Italian. I'm a lucky guy. Technologies and slides are working. Before telling you what Synhelion does, I'd like to start with a strong message. It took me a while to fully understand, and which is also part of our mission. meaning liquid fuels have a central role in the energy transition and in the decarbonization process. Liquid fuels cannot be replaced. We can do whatever we want. We can do a lot with hydrogen and electrification, but there are applications where both hydrogen and electrification are not enough. Take, for example, aviation. If you do some number crunching and take all efficiencies into account, and you understand that in order to have electric airplanes, you need 4 times, both in terms of mass and volume, in order to have the same amount of energy for a plane. So that's not enough. That's not good enough. We can improve batteries with a multiple of 4, but that's not enough. So hydrogen-driven airplanes have not been designed, and it won't be easy to design. Liquid fuels, on the contrary, exist. There is a huge infrastructure that cost 3 billion euros, so they can be used. Whenever we burn in hydrocarbon, the combustion result is the heat we use for any process, and then the chemical product is CO2 and water vapor. But if I use the very same amount, starting from CO2 and water, and I turn them into liquid fuel, I end up with a neutral cycle. Of course, this needs a lot of energy, and I will be telling you what we do. Synelion is not the only company. There are other companies, for example, using biomasses, electrolyzers. There are several paths available. However, the key message is that liquid fuels are essential, and there are alternatives. Even if storage was inexpensive, you still need liquid fuels for some applications. We will be able to produce on the other side of the planet, and we will be able to really overcome seasonal issues. There are lots of things we can do with hydrogen, with biomasses, in a very efficient way. So this is the key message. Liquid fuels will be essential. What Synelio does, it is trying to use the least expensive renewable energy on the planet, which is solar energy. Solar energy is abundant in this planet, and solar concentration is one of the least expensive renewable resources. There are a number of reactions that enable us to revert combustion at high temperature. So we concentrate the solar reaction, and we also feed a process. Thermal storage is less expensive than batteries, and this is what enables us to have what you see here on the picture. This is a pilot test. It's the first system on the market. This is based on the so-called GHR wood reforming. We called it the Shrek. It weighs 12,000 tons and it's 6 meters high. So that's the plant we have in Germany in close cooperation with wood. It's a big plant for people like us working in the solar industry. For you, oil and gas people, it looks like a tiny thing. So this is syngas. This is the central material that we then transform into liquid fuel using different methodologies. But I'd like to close my presentation showing you this roadmap. I'm not trying to sell this roadmap to you. This is not a sales speech, but this is our mission, and it should also be the mission of any competitor working and any player working with liquid fuels. We need liquid fuels. Unless liquid fluid are made available, we won't be able to reach the targets that have been set by any government. After the plant I showed you before in Germany, which is a wood reformer-based plant, and incidentally, this is a small plant because Germany is not the best place to start a solar plant. And indeed, after 2025, we will move to Spain with a commercial plant. And then at the end of the next decade, 2030, we want to cover half of the Jet 1 Swiss market. You know, Swiss people love to fly. And then by 2040, we want to cover half of the European consumption levels. You know, in 2040, we will want to get to half of the European production. But what about the rest of the world? There is still a lot to do in order to reach the net zero target. And finally, price. Price is always crucial. I mean, you can develop whatever technology you wish to develop, but then it all boils down to cost. If you don't want your product to be an elite product, a product used only by the minute minority, we want to develop technologies with comparable price. The Jet 1 cost is currently is going up right now. A year ago, this slide would have looked very differently. But our ambition is to produce at costs that are at least comparable. We won't be able to have exactly the same price. That will be impossible. Sometimes you have some American startups selling at prices that are lower than fossil fuels, but that's impossible. Maybe twice as much or 3 times as much. That's something acceptable, but no more than that. And this is what we're aiming at. Comparable costs, no more than 2 or 3 times higher than current costs. Thank you very much.
We appreciated, as you were saying, your very clear presentation, as usual. Liquid fuels are certainly very important in order to head where we all wish to go. I have a question. Synhelion was the result of an idea. We can define it as a startup, or was a startup a few years ago. Today, it's a reality. You're speaking of a first commercial plant available by the end of this decade. So, if you were to identify something which was key in this passage, in this path, what would you say? What was so important to transform Synhelion from an idea to a reality? What was key? Our partnerships. And of course, that's the topic of this event. And so you must have said, let me prepare the questions. So I'm revealing your cards. But at the same time, it's important for this message to be put across with its real truth and strength. So when you asked me, I said partnerships, and he said fantastic, because it's truly this way. We started off in 2016 with E&I, and then we added others. Next, one of the greatest producers of cement in the world. We work on green cement, wood, Lufthansa Group, SMS Group. These partnerships give a lot of solidity. So when you first launch a new idea or a family of ideas, a vision and ideas, people say, yeah, okay, but then what do you really want? But if you involve some partners, people start listening, especially if the partner has credibility. And this is something very important, not just at the beginning when you go to investors and ask increasingly for money, because to do these technologies is very expensive. Unfortunately, we're not software experts. We can't just use a few developers and have a scalable software. This is not the world of energy. You truly need a lot of money. And to have solid partnerships is a fundamental element, which has allowed us to reach this point. And I'm sure that we'll do great progress in the future too. Thank you, Gianluca. Thank you. At this point, Valentina, you can resume and chair the second initiative linked to the market of H2O, that is biohydrogen. Exactly. Yes, we have a further initiative, which is outside of the traditional set of colors associated to hydrogen. We haven't positioned this amongst the colors. We just called it biohydrogen. What is biohydrogen? It is simply a change, a new declination of the steam reforming process, which is not applied to fossil feedstocks, but to liquid feeds of biological origin, these so-called liquid biofeedstocks. And we can position this halfway between the production of green hydrogen, the production of blue hydrogen. It is a carbon neutral solution, neutral in terms of the carbon footprint, and if associated to a process or a technology for CO2 removal, it can actually become carbon negative. I'm not going to dwell too long on this slide. I just wanted to point out that this initiative covers a technological void which exists between the production of hydrogen from water and the production of hydrogen from biomass. Amongst the advantages of this technology, apart from the fact that it produces hydrogen in a renewable way from a series of non-edible bio feeds. This technology does not require the use of fossil fuels. We said that it's carbon neutral. And differently from electrolysis, which is the only competitor in the production of renewable hydrogen, it allows us to produce SNG, which can then be used for chemical synthesis downstream of that is for qualities suitable for downstream SNG production. Moreover, as it doesn't depend on renewable electricity, this fuels, as you can see from the data, it actually increases the availability of the plant, which is totally comparable to any other industrial plant. Moreover, as this is a new optimization of steam reforming process changing the feed, we can say that the planning and design of these plants does not present particular differences from H2 traditionally produced from fossil sources. And that's why it's very interesting to apply this to revamping and decarbonization projects of existing plants. As for the state of this technology, we can say that the real challenge is the chemical part, because the reforming of these heavy liquid bio feeds can lead to carbon deposits. And so we have to use the technology in such a way as to avoid this issue, this problem. We've carried out different tests on 3 different feeds in a lab. We are now in the initial stages in designing a pilot plant. The tests were successful, and so we are also developing the next stages in order to be able to commercialize, to launch this technology on the market. For biohydrogen, we have developed, together with SimLogic, the development of an economic assessment, which allows us to calculate the production cost of biohydrogen according to the market and the geographical area. Moreover, the tests carried out in the lab were carried out thanks to a strategic partnership with Clariant, which has provided us with the catalyst. On this topic, it is my pleasure to introduce you to Simone Colombo. Okay, come closer to the podium, and you're tall. If I stand, I'm so small, I disappear, where you're tall. He is the chairman and co-founder of the company SimLogic. It is a spin-off of the Polytechnic of Milan, and thanks to biohydrogen technology tests. They've helped us to test this in labs. The biohydrogen technology giving us access to the labs. So SimLogic deals with risk analysis. So do interrupt me if I make a mistake. Simone Colombo is a professor at the Polytechnic of Milan University, and he has a chair in this subject matter. Please tell us what you deal with and how this work has been carried out. Yes, thank you, first of all, for your invitation. I've just come from an event. It was my first speech at the Web Summit in Lisbon, 60,000 people. And here I see that your event has 12,000 participants. Congratulations. I didn't know about this. I'm honored to be present. Thank you for the invitation. SimLogic, as Omar said, is a spin-off of the Polytechnic University of Milan. We engineer decisions, or the decision, with an approach based on risk, which assesses the uncertainty of it all. So we carry out simulations. We are part of the so fashionable artificial intelligence with difference. We don't process data. We do not belong to the data science world, but we belong to the world of the decision-making science. We are plant experts doing machine learning, are IT specialists. And so we try to support decisions which have a very high uncertainty content and typically don't have data available, only have part of the data available. If you think of all the decisions which take place within a company, from the intermediate level to the so-called shop floor, to the production level, you have a lot of data, and then we can discuss on quality, cost of data, and so on. But the higher you go in the company, you have to take strategic decisions. Well, those who have to take these decisions, and what Pandolfi and Bellomo said was right on target. You spoke of uncertainties and lots of risks which must be taken into consideration. And often they are something intangible or non-measurable. And you who have to take decisions know that this exists. So to use data available is great when they're there and they're relevant, because sometimes they're not relevant, but they're used all the same because it's data and must be used. But if they're not relevant, what do we do? sim logic, simulation logic. We do logical simulations. We start off from a different principle. We start off from a logic. We create constructs, that is objects, which allow us to simulate. Now I'm going to use another fashionable world, digital twin. I have a process and then there's a digital twin. And what we try to do is try to capture and enhance all the different competencies which the company has in a quantitative and qualitative way in a process which then allows us to reach something which is quantitative and simulated and allows us to make forecasts, that is complete scenario analysis and take structured decisions. In the case of the work done with Omer and Wood, they were transferring a new technology on the market. The uncertainty was what might be the cost per cubic meter according to the country. There are lots of variables which can be linked to the plant itself, to the supply, the position where the plant is positioned, and also geographical positioning, because I can sell a plant to a customer who has the money but must decide where to geolocalize the plant in the world. So all this complexity is captured in a model which pools together all these different aspects. And starting from design, planning, marketing, the industrial plan, the design and technological transfer, all those elements where one would like to have a quantitative support, but it's difficult to obtain. And so we are part in that rather new niche, which is called decision engineering. So in our case, risk-based decision engineering. I hope I was clear. Yes. It took some time for me to understand this in advance, but I'm in a situation of advantage. Simone is so prepared. He didn't even use the 2 slides he had available. Oh, I'm sorry. I'm sorry. Let me just show you these 2 slides. This is the only decision which might interest you. I put 2 or 3. So here we just show how it works. We recreate this model, enhancing all the different competences and enhancing data if it's there. We do analysis. After that, we see which is the level of uncertainty or risk associated to the parameters which are important. And then what do? It's not enough. We have to engineer the decision. We identify on the basis of the criticalities identified which are possible solutions. We try to implement them to start the simulation again to see if they're truly efficient or not. So that's what we do. That's it. That's all. Thank you, Simone.
Thank you, Simone. Extremely clear. Well, there was no need to show the slides, as a matter of fact, because you had been so clear yourself. Today, here we have representatives from the valve industry, meaning people that on a daily basis take very hard decisions against a highly indecisive market. Could you give us an example of how you could help these people take their decisions? Let's say, there is this new market that has to do with the energy transition and with hydrogen. I imagine the new products will be developed. For example, valves, new valves. Well, how can this scenario be supported by you at SimLogic? Well, we often start from the product. We are plant engineers, so we start from the product. And when you manufacture a product, there are several decisions to be taken. So those decisions are part of the process that can be supported by us. We started working to really support complex technologies related decisions. But then one might ask, how can I transfer this technology? You were mentioning valves, which means megatronic, I guess, not just a piece of iron. So this is, again, another complex piece of the jigsaw. Probably they will also have some IT issues involved. And then there is the problem of putting this new product on the market. There might be political, economic, or even supply related issues. Then we will also have to consider additional aspects, additional variables. For example, geopolitical stability, relationship with stakeholders, with suppliers, competition. Yes, competition will also be considered. So you see, this is the entire process, from the design, from the initial idea to the final manufacturing. But even an improvement of existing production processes can be supported by us. Sometimes when people talk about technical processes, they think about the technology only, but that's not enough. There are three elements, provisional and quantitative data. Sometimes you have fantastic technology, but then the organization behind it, the human resources you need for that process are not the optimal ones. So these are all things that must be taken into account. I hope I answered your question. Well, yes, very clear to me. But anyway, we have a Q&A session at the end. So if people have doubts, I'm sure you'll be kind enough to clarify. Thank you. I think it's now the turn of another partner, of a second partner that we have, Clariant. We have Andres Coy. Please come to the podium. Andres Coy is Business Development Manager at Clariant. Clariant is a multinational company based in Switzerland, a very important company when it comes to chemical productions and also catalyzers. Clariant has been a partner, catalyst, sorry. We have been partnering for a long time. We have been working hard on hydrogen and biohydrogen, and we will then have another presentation by Marianna that will be focused on another very important piece of technology. So, Andres, the floor is yours. I think you have 2 or 3 slides for us. Grazie a tutti.
English. So a few words about Clariant. We are a chemical specialty company based in Switzerland, and we have different business lines within the group. The one that I'm representing today is Clariant Catalyst. We are an independent catalyst supplier with more than 150 years of experience in the Clariant in the catalyst business, with a broad portfolio for different applications from syngas, refinery, petrochemicals, and special applications. And of course, in case that you have also your own catalyst formulation, we can help you with the scale up of the formulation to have a commercial catalyst. We strongly believe in innovation, and we develop technologies through different partnerships with different technology providers. We have a global footprint, as you can see in the slide. And here I want to highlight the challenge that we have embraced to develop technologies to support the energy transition. We, as an independent catalyst supplier, we partner with different engineering companies to develop these technologies and make it commercially available. So basically in Clariant we have 2 streams. One that is the valorization of the CO2 as a feedstock, and the other one is for the hydrogen economy. So let me go through the different initiatives that we have within the slide. So the first one is the sustainable aviation fuels. Probably you have heard that this is one of the most challenging sectors to decarbonize, similar to the marine fuel, and won't be difficult to avoid these sectors by the electrification. So the most suitable technology to help them decarbonize is with liquid fuels. In sustainable aviation fuels, there are 7 certified routes by the ASTM. We're working in 4 of them. And for marine fuels, we can either use methanol or ammonia. Yeah? Then we jump into the middle. We have the methane, where we are working with wood for already like a couple of years to bring this technology to valorize directly the CO2 or also to the syngas produced via the gasification of biomass or municipal solid waste and to get the fuel. Then we have everything related to the hydrogen economy. So we have the catalyst for the production of blue hydrogen and blue ammonia, blue hydrogen or green hydrogen, green methanol, green ammonia as well, and the purification of the gas streams that is one of the most challenging parts whenever we are looking at these no traditional feedstocks. And once we produce the hydrogen, one of the challenges is how we are going to transport the hydrogen around the globe. So here the energy carriers, especially ammonia, plays an important role, and we have the technologies for the ammonia synthesis and the ammonia cracking. And depending on the scale, also makes sense to have the liquid organic hydrogen carriers, which we have also developed. Yeah? So we began working in these energy transition topics in Clarion around 10 years or 12 years ago. And this is a continuous process. We engage in a continuous cooperation with different engineering partners to bring the technology and to make it commercially available for the public. Yeah? I'm happy to take your questions afterwards.
Okay. Can I ask a question myself?
Yes, of
direct
course.
question to you in English, so that you don't need even the translation.
Perfect.
Is it fine? Okay. Andres, we understood that Clariant is very well and very deeply engaged in the energy transition with several initiatives.
Correct.
Do you think there is still space, back to hydrogen, do you think there is still space for a company like Clariant to develop something new in the hydrogen space, maybe new catalyst, new products that may push the hydrogen production to a different, let's say, level of efficiency, level of competitiveness, for example?
Correct. Yes, for sure there is always room for improvement, and the catalysts play an essential role enabling the technologies to be more efficient, to reduce the energy consumption that at the end translates in reducing the carbon footprint of any technology. Yeah? So in Clariant, we are continuously developing and researching ways to optimize the catalyst, to enhance the reactions, but also to improve our catalyst formulation in order to reduce also the impact that it may have in the environment. Yeah?
Thank you very much, Andres.
Super.
Thank you.
Okay, thank you.
We will listen to you later on in the methanation stream again.
Correct.
Thank you. Ok, adesso possiamo direi chiudere, facciamo un wrap up del stream dell'idrogeno.
Wrap up on the hydrogen stream. Valentina, give us some 3-4 take-home messages, and let's try and summarize all the things that have been said. Well, during this session, we have talked about 2 streams of technologies that can be used to produce hydrogen in a sustainable and competitive way. We've talked about blue and biohydrogen. A crucial aspect of these 2 technologies is that they represent an optimization of the traditional vapor-based reformers. All the components involved in these plants and in these processes are valves, reactors, exchangers that are not different from traditionally used technologies, i.e. technologies that use fossil fuels. Blue hydrogen production reduces CO2 emissions with the integration with the situ capture. Biohydrogen is the response to market needs of producing hydrogen from renewable sources. The big benefit is that biohydrogen is totally independent from the electric grid. Well, I hope that this session managed to show that if we want to reach the ambitious net zero targets, i.e. the so-called energy transition marathon, we need strong cooperation with industrial partners. That's why I'd like to end thanking Synelion, Simlogic and Clariant for having been part of this presentation. Thank you very much. I think you will all agree in saying that the GHR, which is a technology enabler, would have not made it without the cooperation of Synelion. Of course, Synelion needed to test their technologies. We had to test our own technology. That's why we agreed on this marriage. The same holds true for Clariant. Without Clariant, we would be going nowhere when it comes to blue hydrogen. So Clariant made this biohydrogen initiative possible. Without Simlogic, we would have no idea of what to do with our biohydrogen technology, particularly when it comes to prices. So I want to thank our guests. I want to thank our partners. Thank you very much for your continuous support and for working with us. I have a very quick question for Valentina. We have understood that hydrogen can be produced also with very low environmental impact. So the question is, we started by saying that hydrogen is the king in this, is actually the prince of this energy transition, but it is not the king yet. What will it take to make hydrogen the king of this energy transition? Well, I think what we're still lacking is the regulatory framework. And for example, there is a strong debate on the use of existing grids. Several studies have demonstrated that we can inject up to 20% of hydrogen into the existing gas grids with no particular issue. But then there is another problem, which is the use of CO2 which is captured when producing blue hydrogen. And then storage, CO2 storage is another issue, which means that infrastructure must be updated. Talking about regulations, we're still missing incentives that will boost the production of decarbonated hydrogen plants and the decarbonization of existing hydrogen plants. Thank you, Valentina.
Let us now change topic and turn to an animal, in inverted commas, which we know very well, methane. We know it as natural gas. This is in synthetic natural gas, but it's always methane. I give the floor to Mariana Mercogliano. She has a degree from Naples University after having worked for 7 years in one of the most important EPC contractors in Italy. I'm not going to make names, but they're not 250. So she is part of the Wood Group, where I, Valentina and Angelo work. And at the beginning of this year, she is in charge of hydrogen production plant and methanation. Good afternoon. Thank you. Thank you so much. My task today is that of guiding you within the world of renewable natural gas. We will speak of what renewable natural gas is, what's its potential, and what are the production supply chains. And we'll try to speak of the role of wood within this field, always in cooperation with our partners. So probably some of you are already familiar with the word renewable natural gas or with the SNG acronym. But to summarize, this is substitute natural gas. To give a definition, substitute natural gas is natural gas that can be produced from coal or biomass. In a more green context, we will speak of renewable natural gas when this natural gas is obtained from green renewable sources. You have often heard the word natural gas. That's what we're talking about. We're talking about methane, only that instead of being extracted from the sun, that is, instead of being a natural resource, it is produced chemically through a chemical process. So here you can understand the potential of RNG, because it offers a great opportunity to all those countries which don't have a lot of natural resources. And if you wish to place this in a historical context, the one we have seen in the last few months and year, this is also an opportunity to be able to try to reduce our dependence on the extreme volatility of natural gas prices. We all know that the war in Ukraine and our dependence on Russian fossil fuels makes this really interesting. Renewable natural gas offers an opportunity to act directly on end users. As we're using of methane, it's the same gas which we normally use in our houses for residential heating and mainly for cooking. And the methane we use also in the transport field whenever used, and also in cogeneration energy production and cogeneration in general. And with Valentina previously, speaking of hydrogen, they mentioned that this is trying to hinder the development of hydrogen because there are some infrastructural problems. In this case, methane doesn't suffer from infrastructure because the RNG we produce with chemical processes can be injected directly in normal infrastructures we already have. And so it can be distributed, reaching the end user. Another important advantage of RNG is that all the technologies which are normally used in the gas supply chain, that is, smell systems, drying or purification of gas technologies, already exist. They already mature. They already are introduced in the gas supply chain and must be put into context again. But it's not anything new. You must have understood which are the main advantages of RNG, and these have attracted the attention, therefore, of governments and institutions who are supporting the development of this new technology. The European Union, with the Repower EU program, which concentrates on the decarbonization of the energy field, set as a target for 2030 the increase of biomethane and RNG to 35 billion cubic meters. It's not a target left by itself, because together with this, it has fixed a series of incentive mechanisms to support all those initiatives wishing to promote this type of technology. And then each country of the Union applies individually in its own jurisdiction with measures. In Italy, we have the Recovery and Resilience Plan. I'm speaking of Europe, of course, because it's the context which is closest to us. But there are mechanisms of this type in other countries, especially in North America. Let us now turn briefly to the main production pathways of RNG, renewable natural gas. There are three main alternative paths: biogas upgrading, power to gas, and production through an intermediate step, which is gasification applied to various sources. In the case of biogas upgrading, biogas obtained from the fermentation of organic vegetable or animal residues is treated with hydrogen. To guarantee the sustainability of the process, it should be a hydrogen produced in a renewable way. And in this way, through a process which we will call methanation, we obtain the production of RNG. In a similar way, in power to gas, renewable hydrogen, instead of reacting with biogas, is combined with CO2, and the process is always called methanation. Obviously, these are very simplified indications to show you the different elements involved, but there are intermediate stages I didn't report here for purification and treatment of the gas. And then the last approach is through gasification. In the case of gasification, biomass feed or waste, even municipal waste or plastic, is treated with a thermochemical process, which is gasification, to obtain syngas. Syngas is a gas mainly made up of CO2 and hydrogen and CO, which is very important for the production of different forms of energy. And we apply a methanation process, which is promoted through special dedicated catalysts to obtain renewable natural gas. I wanted to attract your attention above all to to the fact that gasification in recent years is becoming increasingly present in the energy scenario, and it offers great flexibility because it acts as a bridge between a residue, which is biomass or waste, and a form of energy. And it has the great advantage of offering energy forms to all those places where these natural sources of energy are not available. And this refers to energy security, one of the topics mentioned at the beginning of the meeting. This is a very important point. I'm not going to spend other words on gasification because we have here Jeffrey van der Linden, who will tell us about Ecotech, which cooperates with wood for quite some time now, always with a view to offering integrated solutions. And we try to cooperate and unite our efforts. On the one hand, gasification, on the other hand, methanation, but not just, other technologies too are involved, in order to tackle greater challenges and to give our customers a complete package. Let me now turn to the contribution of wood within the field of methanation. Now, if I were to quote the main characteristic of methanation reactions, it is certainly the great exothermic reaction. It frees up a lot of heat. It leads to an increase of temperature within the system, which makes the process rather complex in terms of control. In the majority of the technologies we find on the market, this problem is solved by implementing a recycling of the product. The product I obtained as an output, I recycle it upstream of the methanation reactors. It's like introducing a diluent within the system. I increase the volume without introducing a new reagent system. And this, therefore, allows us to contain the increase in temperature within the system. Obviously, this is made possible thanks to the installation of a recycle compressor, which is in charge of this operation. Another characteristic is that you have to check in a very stringent way the composition of the feed gas to achieve a renewable natural gas upon exit, which is on spec. It respects the existing rules and regulations in order to be introduced into the national grid. Wood positions itself in the field of methanation with a technology called Vesta. The Vesta technology is a once-through technology. It does not foresee any recycling. Perhaps the suppliers of compressors are not very happy about this, but in this case, we do not have a recycle of products, but this thermal effect, advantage effect, which allows temperature to be limited, involves CO2, which is released, and also steam, which is injected within the reaction system. So these two components together allow us to eliminate from our process setup the compressor, and which implies, of course, great savings in terms of capex and also operational costs for the plant itself. Moreover, this is a very flexible system which does not require, in this case, because of some of its specific characteristics, a strict control of the composition of the gas upon feed. Here too, I'd like to go back to a concept which was already mentioned in the previous presentation. These are systems which, in terms of equipment, do not have technological complexity or revolutionary equipment or something extremely new or complex. We are speaking of fixed bed reactors, control systems which are traditional with valves, control loops and tools which industry already knows about and which must only be positioned within a new process. As wood, we have carried out some numerous basic design packages for a Vesta technology. A pilot plant in China was set up a few years ago and in all the test campaigns has successfully demonstrated production. And we also have a demonstration plant in the UK financed by the Transport Department of the UK, which will use RNG from biomass gasification. What I haven't said yet is that the Vesta process also comes from a cooperation agreement, a fundamental cooperation with Clariant, which has developed, thanks to its experience in the field of methanation, its own proprietary catalyst, which is used within methanation reactors and which offers great performance levels in terms of conversion vis-a-vis the end product. Not many examples of carbon deposition and less complexity in all the different operations. That's all I want to say. I give the floor to Andres, who's more expert than I am on catalysts.
Well, Mariana, you are taking my job away. You've spoiled our key guest, Jeffrey, and you've also introduced Andres. Well, grazie. Adesso non voglio annoiarvi con tutti.
In the previous slide, I shared with you, let's say, the different technologies that we have available to decarbonize the industries. And let's talk about specifically, it's not working, okay, about the methanation and why we believe that the renewable natural gas will play an important role in the energy transition. Yeah. So if we look at the left side on this slide, we can see the breakdown of the natural gas consumption by the different segments. And this is just basically to reinforce the message that there are some sectors which are really difficult to abate and that they don't have the infrastructure or other alternative. Because we need to consider that the cities, they have also a carbon footprint, and there is no quite easy alternative to reduce that whenever we use, for example, hydrogen. Industry is also relying on this fuel, and we are not, or we are aware of the constraints and the impacts that the disruption in the supply chain of the natural gas from Russia has generated in the economy, yeah? That is translated in the inflation that we are suffering basically everywhere in the world. So the natural gas is the second global energy source, and before this, constraint in the supply chain, it was expected that the demand will continue growing until 2050. Yeah. So Mariana explained already about the technology, but the biggest advantage, as I said, is that we can take advantage of using the existing infrastructure for the cities, the industries. It's just basically the same fuel, but with a different origin. Yeah. On the left side, Mariana showed the process. I'm going to show the chemical reactions here. It's an exothermic process. It's a technology which has been proven in various, on different demonstration projects with different technologies. We have an extensive know-how in this kind of reactions for different applications. One interesting topic about the implementation of this kind of technology in Europe is that it's supported by the European Union with incentives. And now in the United States with the Inflation Reduction Act, we can see also how this technology is gaining momentum there. Something else about the potential benefits, it also, the use of methane enables the long-term storage of renewable energy, which is also an attractive option for the seasons. And as I said, we just basically replace the fuel for the same fuel, but with a different origin. And I just want to close here because referring again to the slide that I show you with the different initiatives that Clariant is involved for the energy transition, probably you have heard about power-to-X and waste-to-X technologies. Yeah? So here is just to give you an overview and explain the difference between the two technologies. Whenever we refer to power-to-X, basically we are considering CO2 and valorizing it with green hydrogen to produce chemicals and fuels. And the main difference between power-to-X and waste-to-X is the carbon source. In the waste-to-X here we are taking valuable materials such as biomass, municipal solid waste, industrial waste, and through different processes, mainly gasification, produce the syngas, and then we can upgrade this syngas, once we clean it, into different products. We have one upgrading loop, which is the waste to gas, where we can produce the renewable methane, or we can also produce hydrogen. Yeah? If we go in the other upgrading loop with the waste to liquids, we can either produce methanol or other fuels, especially for the sustainable aviation fuels, marine sector, but also chemicals. And there is also another alternative that we have in Clariant, that in case that you have biomass or agricultural waste, that we can transform that through fermentation in second generation ethanol, which is also a building block for fuels and other valuable chemicals.
Thank you, Andres. Well, it's a good point that at the end there was the second generation ethanol, because it recalls basically our biohydrogen production technology under development, because it's basically the feedstock to our biohydrogen production technology. One question to you, Andres. You are, I mean, in all these processes, Clariant is basically the scientist. What is the biggest challenge you face when we take the phone and we say, Andres, we have this opportunity and it's downstream this kind of gasification, we have this syngas quality. What is your headache, let me say?
Okay, that's a really good question. Whenever we are dealing with these non-traditional feedstocks, we usually find different kind of contaminants, and we need to address that in order to protect the catalyst lifetime. Yeah. So whenever you call us, every time, despite that we are producing the same product, for example, methane, every project is a customized project. Yeah, because it depends a lot on the feedstock, and we can say that we are producing methane from woody biomass. But depending on the kind of woody biomass, we will have a different setup for the purification stream and also the catalyst layout. So those are, let's say, the biggest challenge that we're facing, that everything is customized. We cannot apply one general solution for everything.
So again, the message is that we talk each other,
yeah,
and we try to find the solution, basically.
Correct.
And this gives me the assist. We are having the World Cup in these days to introduce you Mr. Jeffrey van der Linden. Jeffrey is COO or EQTech. Thank you very much, Andres. COO of EQTech. EQTech is a company who developed their own technology. They are experts in the thermochemical conversion of various feedstock, and they developed their own technology for biomass and waste gasification. Jeffrey, the floor is yours.
Thank you very much. It's very good to be here, and thank you for accommodating my English. I think the first important thing to say, even before we talk about methanation or we talk about hydrogen production, which we're also working with wood, it's important to say that EQTech as a company is solving for the problem of waste. And Andres has given me a very good introduction there, because there are problematic wastes in the world, and part of our vision is to see to it that all types of waste, or as many types of waste as possible, become fuel. They become inputs that we can use to create something valuable from it. We are doing work. We are a technology, innovation, and licensing company. We have 2 R&D facilities, and we're looking at more. We have built several plants. Our longest running has been running now for 11 years. I'll come on and talk about that. But coming back to the point of waste, we are looking at wastes from industrial wastes, industrial sludge, wood, but contaminated wood that includes hydrocarbons, but also includes varnishes and stains and things you would find on a demolition site from construction. We are looking at municipal wastes, and we are looking at all kinds of biomass wastes. For example, we have a series of projects in California that are looking at the forestry waste, the brush that causes forest fires. It accelerates the forest fires that we see all up and down California. One of the benefits of what we do is that we're able to build at a small scale as well as a mid-size or large scale. And that allows us to locate plants where waste is located. And so coming back and finishing up on waste, our goal is to get to wherever the waste is and find that. Now that has implications for your industry and your sector as much as it does for ours, and I'm eager to come on and talk about that. To do that, I'd like to introduce a little bit more about EQTech. The technology, and you can see our CTO there in the blue shirt, he is the inventor of the technology. He's been working on gasification since 1997. Our team, we have 4 PhDs and about 20 engineers based out of Barcelona in Spain, who are experts in their chemical engineers with a focus on gasification. I think it's fair to say, with the exception of some of our successful colleagues up here, that as an industry, gasification has struggled so far to be successful at commercial scale. And that's where I think a lot of effort, wood is certainly at the forefront of driving a lot of the change there. But with gasification, we've been operating now for over a decade at the plant in Spain. Movialsa is the name of the customer. For 11 years now at 90% operational availability. So 90% operational uptime, which of course makes it commercially very viable as a business for them. It's a 6 megawatt electric and thermal energy plant where they take the waste from a large agro-industrial facility, they process it, and they turn it into power, but also thermal energy to power their industrial processes on the site. Anything excess that they don't use, they can sell to the national grid at a preferential tariff. And as I say, that's been operating a long time. We have built in total 2 R&D facilities and 4 commercial scale plants. And I'm very happy to say to you that we're launching another one next month in Toscana, in the Val d'Orcia, nice place to visit. let me know if you want to visit. It will take agricultural waste from the local farming cooperatives, and it will convert that into electrical power in the first instance. We also have the opportunity to do thermal energy from it, but also biochar, which many of you might know there's a growing market for, particularly in agricultural communities in Europe. Versatility, I'll come on and talk a bit more about, but one of the differentiators of what we do that's different, and I think many of you will appreciate this, is that similar to what Mariana was saying about the integrated notion of how we're working with wood on the technology solution, the EQTech syngas solution, the gasification solution, covers everything from feedstock all the way through to syngas production. So we are not producing a singular piece of equipment that is part of an overall process. We are producing the entire process. And we produce not only the process, but the vessels in that process, and then the control systems that manage that process end to end. I'll say a bit more about that later. We're clean. Of course, that's critical, because not only do we want to reduce the carbon footprint and indeed the methane challenges and other challenges, the nitrous oxides and so on, from waste products, but we also want to control the process in a way that it has clean offtakes, such as for methanation. We have a very experienced team, I mentioned, and as I said, commercially, we already have a number of plants up and running. Syngas, or synthesis gas, I think many of you know already, it's an intermediate fuel. So it allows us to take a wide variety of wastes, convert it into a synthesis gas, and Mariana said earlier, that's composed of hydrogen, methane, carbon dioxide, carbon monoxide. And we're able to take that, put it through a process, clean it, or tune it, we like to say. And this is, again, part of what we do for whatever specific application you want to use. Now, that for us is both a blessing, but also a curse. Because as a small and growing business, we have to make a choice about what do we do in the marketplace. And with wood, we know that methanation, methane production, but also, synthetic or renewable natural gas production and hydrogen are both good options. But we have to decide how to do it. This is how the processes look side by side. Mariana has already taken you through the Vesta methanation process that wood brings to it. But what you see on top here is the EQTech process. And as I said, we designed the whole thing, and we specify all of the vessels that go into it. And we do that based upon the commercial model or the financial model of the business that's going to run this. So we are able to take a wide variety of feedstocks, and within certain limitations, we're able to produce and maximize the components we want. Now, I happen to have put in here a hydrogen example, but we do the same thing for methane. This is the composition of the synthesis gas that we have produced in past where we want to maximize the hydrogen component. And as you see, it's about 1/3 hydrogen. The methane component in this instance is quite small. Obviously, for methanation, we would be maximizing the methane component. We're able to then, we have carbon dioxide and carbon monoxide, but you'll also see here that the hydrocarbon component is very, very small. And that's another big problem that the gasification sector has faced, because there's too much in the hydrocarbons, and over time, of course, you build up tars in the system, and that shuts down the system. And that has been the problem for the industry. We are able to produce hydrogen or methane offtakes that have a very small hydrocarbon component to them. So I think what I want to close on, having introduced, kind of what we do and why it's different, is to say that the business model impact on this is quite significant. What we're starting to see more and more of is, and I think some of the earlier presentations alluded to this as well, fewer large-scale centralized facilities and many more highly localized, small-scale facilities. If we're going to create waste, leave it where it is. So if you're running a large manufacturing plant, a steel manufacturer, we are working with Toyota, for example, in the UK, a car engine facility is what we have there. Leave the industrial waste on site. Don't move it. Right? Leave it there and right size a plant that fits the scale of what you need there. Right? So that's one big thing we're seeing, and there's 3 examples there, one of which I mentioned in Italy, where we are building where the feedstock is located. The other one is build one at a time was the old way of looking at it. Now we're talking to state and provincial governments about sponsoring many plants. So California is a good example. We see as many as 30 plants in the pipeline in California. All of them are 2 to 3 megawatts in size, same design, same build, same rollout, and we can move at scale to do that quickly. So that's another change that we're beginning to see. And then finally, as I said at the outset, we don't want to avoid, there are wastes that are not as good in a gasification reactor. However, we did trials this past year in France where we have contaminated plastics. We have another plant where we're mixing waste wood, contaminated waste wood, and RDF, which is from municipal waste, all in the same reactor. How can we design, because we have control over the process and the control systems and so on, how can we tune this technology to address the widest variety of wastes and use that as fuel as often as we possibly can? And I think, this, of course, going back to what at the outset of the presentation someone said, this helps also with energy security and energy independence. Because, of course, for small rural communities or for hard-to-reach islands, we get a lot of phone calls from islands who are looking for independence from the mainland or some kind of local facility so that when the grid network goes down, it doesn't impact everyone, it impacts much more locally. These are the types of things that I think might be of interest for your sector as well when we look at building locally and at smaller scale rather than centrally at a larger scale. Thank you very much.
Thank you very much, Jeff. Conscious of time, I ask Marianna to wrap up, and I have a question for Jeff, but maybe we will address it later on during the Q&A session. Thank you very much, Jeff.
Sì, volendo tirare un po' le soppe di questa sessione relativa al metano.
This session devoted to methane. As we already know, we expect that the growth, that there'll be a growth of energy demand, especially in terms of renewable energy sources, with a diversification in the supply of these sources. And the various paths which lead to the production of RNG have already proven to be sustainable from a technical viewpoint and attractive from a commercial point of view. And so these are supported and will play an increasingly important role in this new energy revolution. And perhaps at this point, we wish to highlight once again the importance of cooperating, of joining forces between ourselves and our partners in general in order to try to overcome challenges which are increasingly complex and increasingly great. Thank you. Thank you very much, Marianna. A very last but not least intervention. Let me briefly introduce the person in charge of procurement in our company, Angelo Battaglia. He's been with us for 15 years. Yes, for too long. He's been with us for 15 years. He is the person you might have to deal with when you buy valves or components of different types. I wouldn't like to be in your shoes at that point. I'm going to ask Angelo, as the person head of procurement. Well, we've spoken of transition and energy security. In your opinion, from your point of view, you knowing all about the supply chain, how can the supply chain support, help, and facilitate the energy transition process and managing energy security? What's your opinion? Let me repeat something which has already been said repeatedly. The supply chain, in my opinion, is based on cooperation between those who develop the plant and system engineering and whoever provides the elements to allow this plant to be built. If we didn't have the suppliers of equipment, all those sitting on this side of the room would just do paperwork and nothing would be materially built, in other words. Whereas the cooperation between engineers, designers, plant experts, and whoever plant engineers and those capable of designing the components of the plant is of fundamental importance. I believe that in Italy we have a production framework which, although in recent years this has been greatly undermined, this production setup greatly supports our plant capacity, plant building capacity. And this is an added value which we in Italy can indeed provide. What was presented by my colleagues previously is, in my mind, makes it evident that there's not just one solution. There's a set of solutions for energy transition, and these are presented on the market as an evolution of already existing systems, of already existing plants. And that is why we are not in a brand new industry. We are in an industry where we have new cases, new opportunities, which must be tackled with the capacity and flexibility which you, more than us, have always proven to have in terms of the production market in Italy. I don't know how many of you have noticed that in Mr. Pandolfi's initial presentation, the only question marks concern the supply chain. This because the supply chain, compared to technologies, operates in a less solid, on less solid ground. Indeed, you might speak of being in a quagmire, but we must get our capacity to adapt, to evolve, and in my opinion, this has a major opportunity in our economy. This is a major opportunity. So we are in a quicksand situation. There are lots of question marks, as Mr. Pandolfi listed at the beginning, costs which vary all of a sudden and in a way which is totally unforeseeable. The timing, the time schedules will constantly change too. And with all these uncertainties, there are also a lot of end users who, as they're not quite clear where they should invest, are waiting to carry out their investments. So this is a situation which makes our everyday life very difficult. And I believe that it is only by cooperating, all of us, all the different elements present on the chessboard, both during the engineering stage, but also in the actual building of the plants, that we can think, that we can find a solution which is satisfactory for all. I hope I've managed to reply. Thank you. Yes, you were very clear. Thank you. And so at this point, we can conclude this session. And the greatest achievement is that we're perfectly on time. I hope that this workshop was interesting for you, and I hope that this has left you with some take-home messages which will help you in your everyday activity, and has given you some food for thought to move in this situation of quicksand. It's not easy to move in quicksand, but This is what Angelo referred to. Thank you very much for your attention and cooperation. Our colleagues, the Wood colleagues and the partner companies colleagues were very, very kind. You were really great. Thank you. Thank you very much. As we're in streaming on YouTube, we have some questions. Alfio asks for Mr. Mercogliano, Mrs. Mercogliano, which materials are used in the Vesta technology? The materials which we normally use in the Vesta technology are rather traditional in nature. It depends on the individual equipment we're speaking of. Usually these are low alloy metals, standard metals. The operational ranges of our process are standard and such that it's not necessary then to turn to more sophisticated materials or refraction materials. Nothing special, nothing particularly complicated. I don't know where to look as the question comes from the internet. We also have a second question, Daria for wood. A question for wood. Is it possible to decarbonize existing hydrogen plants? If yes, which are the main steps to transform a grey plant into bio or blue? I think that's for me. It's absolutely possible to decarbonize existing hydrogen plants, and the main steps to convert a plant from grey to bio is for the treatment for liquid feed, the setup of a system of dedicated storage for these new feeds, as well as a check of the existing equipment. And the check of the existing equipment must be carried out also in the conversion of a plant from grey to blue, which also foresees the installation of a dedicated system for CO2 capture, apart from the GHR we saw previously. I want to seize the opportunity to say that within Woods we have other initiatives too, which we are trying to develop with further solutions which allow us to reduce the necessary time to turn the plant off, to shut down the plant in order to have drag and play solutions. I think that, as Valentina said, in the grey to bio transformation, the catalyst is really important. You have to use a dedicated catalyst, and our Clariant colleagues support us in this. Yes. A third and last question, Francesco, a question for wood. We spoke of modular solutions for hydrogen. Is this applicable to Vesta too? Yes, yes. The modular approach is an approach which can be used for Vesta plants. Obviously, each plant is specific. There can be individual equipments which have to be manufactured and transported individually, but the entire plant must be adapted to modules which simplify transport and installation with the client. Thank you. I have a question for Jeff, which I didn't answer previously, but here it is. Jeff, voi siete molto attivi nella gassificazione, però abbiamo sentito, anche se è una domanda forse un po' scomoda, abbiamo sentito
processes that in the past failed. So why you think Ecotech is able to succeed where the others failed?
Well, in a word, I think integration, management of integration risk. And we might need some help identifying the risks. No, honestly speaking, I think one of the things I didn't mention that we also do is we model in advance the behavior of the thermochemical conversion process through from end to end before we specify any equipment or anything else. And that model has been proven consistently to be accurate. I think as we're working with wood on methanation and indeed on hydrogen as well, we're doing similar things at looking and running those trials. But I think what we see a lot of different pieces coming together right now, which 10 years from now might work. But I think for the time being right now, understanding the end-to-end process and all the variables at play in that are absolutely critical for getting the right outcome.
Thank you, Jeff.
Facciamo una piccola pausa, adesso c'è un coffee break che vi attende fuori.
Domande dalla platea? No.